episode 391 of CppCast with guest Yuri Minaev, recorded 1st of October 2024. This episode is sponsored by the PVS-Studio team. PVS-Studio is a static analyzer created to detect errors and potential vulnerabilities in C, C++, C#, and Java code. In this episode, we talk about CppCon 2024, a new coroutine library, and debugging std map. Then we are joined by Yuri Minaev. Yuri talks to us about static analysis and what it takes to write a C++ compiler. Welcome to episode 391 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Timo Dumler, joined by my co-host, Phil Nash. Phil, how are you doing today?
Oh, I'm all right, Timo. How are you doing?
I'm good. I kind of recovered from CppCon. Been back for a couple of weeks now, 1.5 weeks to be precise. And there's the new thing that comes up, which is in about 10 days, we have the deadline for the pre-Wrocław mailing for the committee, which is the mailing for which you have to submit all the papers you want to be discussed at the next committee meeting. So there is a flurry of papers that need to be written and reviewed and commented on, and busy days because we have quite a few features like contracts and reflection and pattern matching and others that are kind of trying to make it into C++ 26 before the deadline. So the feature freeze deadline is kind of early next year. So it's getting tight. So there's a lot of, it's very busy. So that's kind of what I'm doing right now when I'm not recording CppCast. So what about you, Phil? What are you busy with right now?
Ooh, well, yeah, I think I've just about recovered from CppCon as well, but I'm off to C++ Under the Sea next week.
Oh, is that the one in Amsterdam, the new conference? Yeah,
yes.
That is so exciting. Unfortunately, I can't make it this year, but let me know how it goes.
Yeah, no, I'm really excited to see how that's going to play out. As far as I know, you can still buy tickets for it. Not for my workshop, though, on coroutines, because I believe that's sold out. So it gives you an idea of the level of interest in this new conference. So if you can get there, you probably should. So I'm busy preparing for that workshop at the moment, because that's a brand new one. And then I should be able to maybe take a day off at some point.
That sounds like a good idea. All right. So at the top of every episode, we'd like to read a piece of feedback. This week we have an email from George. George wrote, I was listening to the latest episode. He refers to the CppCon special that we recorded there while working in my garage, and heard an individual suggest having an episode on the committee approval process. To my surprise, someone after him seconded the idea. I began saying to myself, no, no, no. I then proceeded to say, hey Siri, remind me to write to CppCast that a committee episode is a bad idea. So checking off this to-do item, having an episode on how the committee works is a bad idea. I was glad when I heard that both of you recognized that the majority of listeners would probably not be interested in this.
Yeah, apologies to anyone whose Siri just went off listening to that.
Mine did. we cut that out. So what do you think, Phil? Should we then just abandon this idea?
No, I don't think we should abandon it. But as we said on the show, we just need to be careful how often we get into that sort of thing and how deep we go. I think some surface level discussion every now and then is fine. Like you were just talking about your preparation for the upcoming meeting in Wrocław. So I think that's fine. But probably having multiple episodes on how deep the rabbit hole goes might be a little bit too much.
Yeah, so, I mean, you also have the local C++ meetup here in Helsinki that I'm running, and we sometimes have these talks that talk about like future stuff and committee stuff, and we actually had a couple talks like that just this week. And the impression I get there is that most people who come to meetups, and I suspect also most people who listen to our podcast, are more interested in things that they can actually use in their code today. So I think we should really kind of try and focus on that maybe a little bit more. I think this is kind of really what's most relevant for people listening to this.
Yeah, absolutely. But if people do want to find out more, where can they go?
I'm glad you asked. So if you are interested in how the committee process works, we do have extensive documentation about that on isocpp.org/std. So you can read all about the process there. Right. So we'd like to hear your thoughts about the show. You can always reach out to us on X, Mastodon, LinkedIn, or email us at feedback@cppcast.com. Joining us today is Yuri Minaev. Yuri works on PVS-Studio as the C++ static analyzer architect. His primary responsibility is to keep low-level stuff in order and add new features to the core module. A bit of a surgeon operating on the open heart of the C++ parser, a bit of an orthopedist inventing prosthetics for the legacy code, father of 3 cats, and a couple of pet projects. Yuri, welcome to the show.
Hi, Phil. Hi, Timo. Glad to be here.
Hi, Yuri. It's an interesting range of responsibilities that you have there, but interesting that you do talk about your pet projects alongside your cats. So you treat your code as pets rather than cattle?
Well, my pet projects are kind of my... I treat them like my cats, more like.
Right.
Sadly, don't have much time for them. But that's okay. I'm not on a deadline, at some point I decided, hey, I want to create a game engine. Sounds great, right? And I tried, and I failed. Yeah, because just if you can imagine how many things, how much stuff you need to put in there. So at some point I decided, hey, I'm working on that sort of compilery thing, like static analyzer. Why don't I write my own programming language?
Of course.
And currently I have a project which it's like a functional Python-y, programming language. It started as a calculator. I just wanted to, create a command line calculator, and it kind of went out of control.
Yeah, that's the thing. You start off writing a calculator and it soon adds up.
Yeah. So at some point you add variables, then you want to add functions, then you do conditionals, and it goes downhill. Yeah.
Yeah, as long as you don't add side effects.
All right. So Yuri, we'll get more into your work in just a few minutes, but first we have a couple of news articles to talk about. So feel free to comment on any of these, okay?
Mm-hmm. Okay.
So the first one I have here is about CppCon, which Phil and I went to just 2 weeks ago. And they have published their keynotes, or at least 4 out of the 5 keynotes that happened there. One by Herb Sutter, one by Khalil Estelle, David Gross, and David van der Voorde. Also, this year's committee panel discussion, which happened there. I haven't seen the 5th keynote yet, the one by Armando Rousseau about safety and security, but I'm sure it's going to pop up soon. They're all not really public in the sense that they're unlisted, so you're not going to find them on Google or on YouTube, but they are online. If you have the link, you can access them. And conveniently, the links have been posted on Reddit, so you can find them there. And I guess we can also include them in the show notes, Phil, is that right?
Absolutely, yeah.
And then you can watch them there for free, and they're all pretty amazing talks. So I certainly learned a lot from them. So I'm sure it's going to be interesting to some of you as well.
By the way, just a bit of inside information about why those videos are unlisted at the moment. This is something that's common across most of the conferences now. Most of the viewings for YouTube videos come in sort of organically through searches. So everything's sort of optimized to cater to the YouTube algorithm for that. And so having it on a staggered release schedule through the year really helps with those numbers. But for those of us that are sort of closer to these things, you just want to get those videos as soon as possible. So for those smaller numbers, it's okay just to give out the unlisted links. So that's what we're all doing now. We're putting them up unlisted. We can share them with the speakers and with the community. That's not really going to change the YouTube statistics. So we get a bit of the best of both worlds.
Yeah, I'm sure you're in the thick of it with all the conference stuff, aren't you, Phil? So you know everything about that.
Well, not everything, but more than I should.
All right. So talking a little bit more about code that you can use today, there is a new library for task-based parallelism, which is called Koros. It's available on GitHub. It's built on top of C++20 coroutine. So it's not the Coro library. That's a different library. It's called Coros with an S. So it's built on top of C++20 coroutines. It's a pretty straightforward interface. It's a header-only library, which is, of course, great if you want to integrate it. It's optimized for performance. I guess you kind of have to do that if you do C++. Yeah. That's kind of the point, isn't it? It also uses std expected for error handling. This is pretty cool. This is a new thing in C++23, so I guess you do need C++23 to compile it, but it's a pretty cool new little standard class to do error handling, which I talked about at some point.
Yeah. They use expected. Does it mean that they don't throw exceptions left and right?
I would assume that they don't, but I haven't looked into the code.
Yeah, they don't throw exceptions, but if they catch an exception in the unhandled exception function.
Yeah, so they just wrap it in the expected.
Yeah. So more interestingly, the library supports monadic operations, so you can chain tasks with things like and then you give it like another one and stuff like that. And yeah, it's all built on coroutines. There's of course lots of questions like how does it compare to other libraries that do similar things like TaskFlow and libfork. There's a bunch of them. How does it compare to the whole sender-receiver thing? Of which there is also like a reference library out there, I think by NVIDIA, I think is now has that now, like lib execution or something.
Right, as well as libunifx.
Libunifx from Meta is the other one as well. Yeah, so there's a bunch of libraries. I'm not sure what makes this one different or better, or why you should use this one, but it's a new project, very modern C++, which I guess makes interesting uses of coroutines, so I thought it was newsworthy to mention.
It's I think it's also for people who developed it. It's a hacker value or whatever it's called. Like when you do things for the sake of having things done, interesting things, and it's like an achievement. Yeah, I can do that. Maybe there's really a need for another library.
Oh, I think we need lots of these, and we'll see how they shake out, and then we'll have previous experience that we can standardize, because we do need some task-based libraries in the standard that are lower level than std execution stuff, because I think that's a much bigger framework for this sort of stuff, whereas this one seems to be much sort of lower level, more at the like std generator level, so it seems to work well alongside that. Just adds a few of the common features and a bit of like there's a thread pool. You can have different coroutines going off in different threads, and then join them at the end with a very simple co-await syntax. And you can even do recursive calls, so you can have a task within a task, and the outer one will await the inner one, and that sort of thing. Stuff that's actually just generally very useful, but not too opinionated. So I think there's definitely a need for this sort of library.
Yeah, and that's the stuff that's very tricky to get right if you want to do it yourself. You had a few talks at CppCon about that, and it's good to have just kind of libraries that do that for you.
I tried to understand that, and I was terrified by how much stuff you need to write by hand just to make it work, like without anything, just with the standard library.
Yeah, I think that's why my workshop next week sold out.
Yeah, I wish I could attend your workshop. I actually spent quite a lot of time trying to understand coroutines recently, because we are trying to make contracts like pre and post conditions work with coroutines, and for that I had to actually understand how coroutines work, or at least to an extent sufficient to understand what was going on there. And that was a deep dive that I don't know. That's probably a bit too much information about what's going on there.
Too much information is the starting point.
So yeah, I think I would really enjoy attending your workshop, Phil, to kind of make sense of it all. But unfortunately, I can't be there. Maybe there's going to be another opportunity.
Oh yeah. There
right. So I have one more news item, which is again about kind of a very practical thing. And it is another great blog post by the never-tiring Raymond Chen, who is writing multiple amazing blog posts every week. I don't know how he does that. This one stood out even from his usual blog posts to me. It's called The Case of the Crash When Destructing a Std Map. And it's all about debugging. So a customer was getting a crash in the destructor of std map in the kind of Microsoft STL, and just kind of send them the crash log and said, hey, my code is crashing. It looks like your STL is broken. Can you fix that? And the whole blog post is basically about Raymond trying to figure out what's actually going on. like figuring out what the bug is, basically just from the information that the customer sent them. And it's just an amazing read. It's like he starts by reading the source code of StdMap, like in the STL implementation that they have, trying to figure out like what's going on, like, okay, what are the pointers and nodes there, like what refers to what. Okay, great. And he looks at the disassembly, he maps that back to the actual code. Then he figures out where like the corruption, the memory corruption happens that triggers the actual crash. Then he guesses, okay, it must be probably this kind of error code. And then he goes on and on and on and on and like, oh, okay, this is not happening here. Okay, let's dive deeper. Oh, okay, it must be that. And then at the end of that, he finds the bug, which is completely unrelated to StdMap at all. And it's an asynchronous I/O operation that was not even happening in the client code. It was happening in some other library that they were using, where there was a bug that there was an asynchronous I/O operation that was started and then kind of just, shot into space and never joined or anything. And then it's like, okay, we have waited for a second now for this operation to complete. Okay, whatever, we're just going to abandon it. And then you kind of just go on and like do something else in that memory. And then much later, that I/O operation comes back and says, oh, I'm done now. And kind of writing its result in like that memory, which just happens to override the root node of that StdMap somewhere in a completely entirely different place.
I liked the analogy he used there. Like, imagine you hire a demolition company to knock out your house, but they can't just go now. So they say, we'll come later. So you are tired of waiting for them and you sell your house and eventually they come and knock that house down.
Although somebody else is living there now.
Yeah. It's kind of sold a million years ago and here, boom, surprise.
Right. No, that's great. I mean, this whole article is just, Jedi Master level debugging. Like absolutely, you can just learn so much just from reading that. Like how he thinks, how he approaches the problem. It's just masterclass. I really enjoyed that.
So the thing that struck me was how he actually has time to do all this debugging when he's knocking out so many articles every week.
Maybe he's delegating articles. I mean, I'm sure he can debug.
Maybe we'll have to try and debug that. Okay, so Timo said that was the last news item, but I sneaked one more in, so I'll take this one because we actually launched the ACCU 2025 call for speakers this week, in fact, just yesterday. So this is breaking news. So if you want to speak at next year's ACCU, which will be running from the 1st to the 4th of April, Tuesday to Friday, then that is open now. And we've also opened early bird tickets. In fact, we're calling them sort of, it's not explicitly called super early bird, but it's like effectively super early bird because there's like an additional discount you can get. And the discount is going to decrease over time during the early bird period. So the sooner you book, cheaper the tickets. So pause the podcast now, go to the website, get your tickets, come back, and then finish the show.
All right. Yeah, it's an amazing conference. I have been there quite a few times now. I hope I can be back next year. I'm pretty sure I can make it. Do you want to remind people where it is?
Yeah, that's in Bristol in the UK. So it's the same venue it's been in for getting over 10 years now. So if you've been there before, it should be familiar. And it's although it's sort of in the west of England, it's very, very accessible from London, especially Heathrow. Just a straight line train, hour or so, hour and a half maybe from Heathrow. So yeah, come to ACCU 2025. And that is the last news item. So we can now get to Yuri, who you were on CppCast back in 2020, back when Rob and Jason were running the show, of course. So what have you been up to in the 4 years now?
A lot of things, actually. Well, let's see. I've developed a new type system for PVS-Studio. We are currently working on a parser. I have 3 cats now. In 2020, I had 1. Right. I finished Dark Souls like 20 more times. Lots of stuff.
So definitely busy then.
It's been productive, especially the cats and Dark Souls parts of it.
I'm sure they take a lot of time.
Cats, yeah, they do.
Yeah. But static analysis, then. PVS-Studio is a static analyzer for C++ and a number of other languages, as we've said. We've had even like since we were last on, we've had a few shows about static analysis. But maybe you can just remind us what static analysis is and why you would want to use it.
The way I usually talk about that is, well, imagine a compiler, right? What it does, it understands your code, and then it generates code for your computer. Static analyzers, they do the same thing, but they don't generate code. They analyze your code and tell you where you made mistakes, basically. Well, you need it really just to make sure your code, because before it goes to production, that it is as bug-free as you can do it. Because, well, usually we even have a diagram like of cost of an error, of fixing an error.
Right.
If you catch it early, it's cheap. If you catch it when, I don't know, your software is uploaded to a spacecraft or something, that's really expensive. So, yeah, you might want to use static analysis just because it will catch for you things that people usually overlook, because people are not good at noticing small things. Like you forgot accidentally to check, I don't know, a pointer or something. It's easy to forget. And it's difficult to see, especially if you're reviewing a lot of code by yourself. So that thing, it's just a little helper that can help you find obvious mistakes, and sometimes not so obvious too. But obvious mistakes are the main focus because, yeah, like I said, people are not good at noticing small patterns and stuff like that.
Yeah, I think those obvious mistakes, when you discover them, they can almost be, well, they can be a bit embarrassing. Like, how did I let that slip in? So they're the ones you really want to get. At least the non-obvious ones, you got sort of some respect. Like, nobody could have thought that.
Well, the nasty thing about those small things, small mistakes, is that sometimes you won't just notice them. Sometimes you crash, and sometimes it's UB.
Oh, yeah.
And you just don't know what happens.
Yeah.
We've had a lot of esoteric bugs, in our own code, which I probably shouldn't say, but who cares? When something really weird happens, like a bug happens only when you consume over a gig of memory or something. And many of them were UB.
Yeah, so I've seen quite a few conference talks by people like you and your colleagues, usually about weird bugs and how they happen, and it's usually quite interesting material. But so the description mentions that it's a static analyzer for C, C++, C#, and Java. So that's quite a few different languages. Can I ask what language the actual analysis tool is written in?
Well, C and C++ ones are in C++. C# one is in C#, and Java is surprise in Java.
Oh, so they're separate products, separate code bases.
3 of them.
Interesting.
Well, right now, some people here are dreaming about making, a unified engine or something which can handle them all. But I don't know, because I don't want to write a C# parser or something like that, because C# and Java, they use that, they use imports instead of like headers. And in C++, it's really convenient. You have a CPP file, which includes everything it needs. And you can analyze the entire preprocessed output. And in C# and Java, you have to build that model. You have to load those imports and stuff like that. That's why for C# and Java, they use, for C# they use Roslyn. And for Java, Spoon. They use it for their front end. Because writing that from scratch, I think it's a little bit more difficult.
Yeah, it always seems a bit almost wasteful to have completely separate implementations of these parsers and analyzers in different languages. But every attempt I've seen to try to unify them, and I've worked at a few places now that have gone down this path, it's never quite worked out.
Right. So how different are these? Like, I'm assuming that you work on the C++ one since we're here.
Yeah.
I wonder how different like the problems are, because in C++ obviously we have undefined behavior. We have all of these things like invalid pointer dereference and whatever out of range that I guess you can detect. Whereas in C# and Java, I guess those things are still bugs, but they're not undefined behavior. So you get an exception. Is that like a completely different game in C++, or is it relatively similar? What kind of problems you find?
I'm not exactly sure how like the other parts work internally, because I'm not going there a lot. But I guess they have also null references and stuff like that. Well, yeah, you will crash. It's not UB, but still you have to catch these errors and fix them. And in Java, I remember they did some checks when new versions of Java were released. They did checks for if you have some code which becomes obsolete in new versions, they pointed that out in the Java analyzer to the user. Right. So you can use an older code base, run the analysis, and you will see parts you need to rewrite for the new version of the language. And that was a request from a customer, I believe.
Do you distinguish between what we might call actual bugs, things that are actually wrong and will lead to problematic behavior, versus what we might call code smells or violations of best practices, where the code may itself be correct, but it's going to lead to problems?
Well, we usually have like diagnostic levels. So right. It will, if it's sure that, okay, that's a bug, that shouldn't be there, it will complain with a high priority. And if it's like, nah, we can let it slide, kind of, it's not a bug, but don't do that, it will complain on a lower level of priority. So the alarm level is different. But like in actual code, when checks occur, they work the same usually for, well, there's no clear distinction. Okay, that's a bug and that's a code smell. Right. For code smells and minor stuff, we usually check the context, some surrounding conditions or something. We can, by using circumstances around the place where this happens, the error is posted. We can guess, okay, probably this was supposed to be there, like he knew what he was doing, or probably that was a copy-paste and something like that.
Right. So they're context aware.
Yeah.
And that presumably implies symbolic execution.
Yeah. We have data flow and symbolic execution.
Right. Yeah. Yeah, which in general is like solving the halting problem, but in limited context, you can actually get quite far with it.
So I actually heard a question about this. I'm trying to wrap my head around the stuff right now. So there is program execution, right? Which is you just run the code and for example, if you call a function, you know what the inputs are, right? Because you literally call the function with that input. And that can happen during runtime or during compile time, which is what we call like constant evaluation, right? Like const expr and stuff. But symbolic evaluation is different, right? Instead of just calling a function with a input, like you're kind of calling it with every possible input or something like this. Is this like a vaguely right, or what is symbolic evaluation exactly?
We go through the function's code inside, and based on how different entities inside that function are used, we can infer some facts about them. Like, for example, let's say if you have a function and it accepts a pointer, and the first thing you do is, if not, ptr return, right? So that PTR gets a label never null pointer and stuff like that. For pointers, it's just really simple. But for example, if you have if a minus b equals 0, you enter the if body. Inside that if body, we know that a equals b because a minus b equals 0, if it makes sense.
Okay.
So yeah, you just gather different facts. It's like it's similar to what an optimizer does on a analyzing pass. So like LLVM, for example, we don't have IR, but LLVM uses IR. What it does, it first goes through instructions and collects data, some information about them, and then it uses that information to optimize. Like it can infer that some variables are, even if you don't label them const in your code explicitly, it can infer that they never change. It can throw them out of your function. It can inline functions. If it infers that a function always returns the same value, it can just replace the entire function call with it. So that kind of thing. It's like an optimizer, but the real optimizer is more sophisticated than symbolic execution.
Does it work like across like different functions or even different instantiation units? For example, if I have one function that returns a pointer, but then something in that function like makes you be able to reason that that pointer will never be null, and then you pass that into another function, do you then know that that function? Do you like look at every function in isolation, or can you like look at the actual flow and deduce that function call must be correct because the other function that you get that pointer from never returns a null pointer or something?
Well, yeah, it can do that. We annotate functions when we analyze them. We analyze one function, we annotate it like we can say that it never returns a 0 or a null pointer or something. There are also manual annotations, like we know that malloc allocates memory and free returns memory. How do then we know that? Because we manually annotated malloc and free, right? Mm-hmm. But automatically we also create such annotations while analyzing. And when you call a function, we can know something about its return value. For example, it's kind of limited, so it's not as good as I don't know, LLVM's optimizer, but it's able to understand things like that. And for across modules, for that we did a special kind of quasi-linker. So to do intermodular analysis, we go and collect information about modules and store it in a binary format. And then we call analysis and use that collected information to understand what functions from other CPPs do.
So I got one last question about this, if I may. So let's say I have a code base and I want to like throw PVS-Studio at it and see if it finds any bugs. Like, how do I do that? Like, do I need to have a CMake file or a Visual Studio solution or like something else that tells the tool like these are the source files that belong to the project and this is how they are related and this is how I compile them, or like a compilation database, or like how do you figure out what the actual code will be that you're going to look at?
Let's see. So you can do a Visual Studio solution because there's a extension for Visual Studio. You can do integration in VS Code, Qt Creator, something else I don't remember. It supports CMake. You can give it a special file, compile commands, JSON. Some tools like CMake can generate it. It's a special JSON file which contains all the compilation commands on your project. You can also, under Linux, you can use strace to trace compilation commands, and then a special tool that we created will parse the output and it will collect all the flags and paths to source files and stuff like that, and run analysis on them. Under Windows, you can use Compiler Monitor, which is also a tool from us, which you started in the monitoring mode, and you build your project, and it will catch compiler calls, and then it will start analysis on CPP files. So there are different ways to do that.
So in some cases, do actually interpret the project model?
Well, not exactly project model, because usually, in Visual Studio, for example, MS Build gives us all the information we need. In CMake does that. So basically, we just integrate and listen. Okay. So we don't have like, what's funny? I was about a year ago, maybe I had that crazy idea that we need to do a PVS Tool Chain. You have a CMake, let's say you have a CMake, and you say build it, but instead of your compiler, use PVS, and then we'll have compiler and the linker and stuff like that, and we will just work as a tool chain. But it's still like a dream. But I think it would be interesting.
Yeah, that's the interesting thing about build tools and tool chains is nobody really wants to have to deal with them, but they'll want to do it exactly their way. Bit of a contradiction, but so is it easy enough to integrate with your existing tools, or do you have to do a lot of configuration?
Usually people just set up PVS-Studio in their CI, and it just runs after builds.
Right. Okay, that sounds reasonable. And you mentioned LLVM. We have Clank tooling, and part of that is Clank Tidy, which is already a static analyzer. So what does it do differently? What does PVS-Studio do differently to, say, Clank Tidy that we already have for free, often built into our IDEs?
If I had $1 for every time I'm asked this question, right? Tidy is a linter. As far as I know, it doesn't have much of semantic information. So if you want to compare PVS-Studio with something, I guess Clank Static Analyzer would be a better comparison. But as for Tidy, well, it's good, but it doesn't dive deep enough, I think. And Clank Static Analyzer, I'm not even sure in which state it is now. I think it's not big enough yet. It doesn't catch as many errors, if I know correctly, because I haven't looked at it for a long time.
Right. Yeah. It's definitely still evolving, and I know some issues that I saw with it even like a year or so ago have been fixed. So it's getting better, but you're right that there's a limit to how far it goes.
Tidy has a really great advantage, I think, because you can write your own rules there. You can write those AST matchers, and they will work like custom checks.
Right. And can be surprisingly easy to get up and running with that. If you've got a specific custom need, it's definitely something to look at.
Well, usually what people here say from people who understand marketing and sales better than me, because I know nothing about it. We have user support and we have integration everywhere. So it's kind of like a big advantage over free tools, especially, which like you take it and you do it and you're on your own in many cases.
Yeah. And one thing I like to say is, you don't have to just use one static analysis tool. You can use a whole range of them. They often complement each other.
If you don't sync in their output, if you're not afraid to sync in their output, because you will be bombarded with a lot of things, especially if you run for the first time and you don't, ignore stuff which is irrelevant. You don't disable checks, which you don't really want. it's like, was it Tidy? It's like Tidy was complaining, you're passing a parameter here and you don't change it inside a function, make it const reference, and when you do it, make it a const reference, it starts complaining, hey, what are you doing, dude? The object is really small. Just pass it by copy. Come on.
Right. Yeah, there can be a lot of false positives like that. You need to tune.
Well, I mean, what I mean by that is not that Tidy is bad or anything. It's just you have to set up what you want to see in the output, really.
Yeah, exactly. Not everything is an obvious bug.
Okay. So, Yuri, we're going to continue conversation with you in a minute. But before we do that, we have a few words from our sponsors this week. PVS-Studio is a team that develops its own tool, a static code analyzer for C, C++, C#, and Java code. Large legacy projects require the full focus of the development team, and newer projects require experienced support. With a static analysis tool at your disposal, your team will write even safer, cleaner, and more secure code. The static analyzer has more than 1,000 diagnostic rules and a special mode for mass suppression of warnings in legacy code. It can find dead code, typos, potential vulnerabilities, and much more. If you haven't tried PVS-Studio yet, now is a great opportunity to do it. Podcast listeners can get a 1-month trial of the analyzer with the CppCast promo code. You can find the link to download the tool in the description as well. I guess description means you're going to put it in the show notes, right, Phil?
Yes, yeah, that'll be there. Go and have a look. So yeah, a bit of a coincidence that we have PVS-Studio as a sponsor for this episode. Not entirely a coincidence. We sort of tried to coordinate those things so that that'll work out quite nicely. But yeah, great opportunity to go and try it out yourself. So having talked about PVS-Studio, just wanted to change gears a little bit because you did mention working on a C++ parser in your bio. And that interested me because I mean, I would assume that you would use something like, Clank tooling and build on top of that. But are you actually doing the parsing yourself?
Yeah.
We
are doing our own thing. Clank would be great, but not good enough. Let's say, I don't mean, again, that Clank is bad, but how we typically work, we support different compilers from different platforms. I mean, code written by them. And what we do, we get a CPP file as input, and we ask the compiler to preprocess it and give us the preprocessed version of the file.
Right.
Without macros, includes, and stuff like that. And then we parse that.
Mm-hmm.
And the problem is that Clank doesn't support everything. There are compilers, especially in embedded world, which have non-standard types, non-standard intrinsics, and stuff like that. And we have to understand that. But Clank doesn't support all of them. Clank would be great if we just did, Linux and Windows, MSVC, GCC kind of stuff.
Yeah.
Well, actually, embedded compilers are usually GCC-based.
Mm-hmm. Yeah.
So we could cover a lot of them, but not all. I remember supporting some 8-bit compiler which had types like int24, int40, and it had a bit modifier, so you could manipulate bits directly somewhere in memory. And its pointers were a flexible size. They could be from 4 to 12 bytes long, I think.
Yeah.
Addresses. It's been a long time ago, so I don't remember the details, but the idea is kind of like that. And one more thing, which I hope dies soon, is we support Microsoft C++ CLI, which is C++.NET. Don't support it too well, but we can at least parse it. And Clank, I think if we gave Clank something like that to parse, it would tell us to go and do something.
Right. Yeah. No, that makes sense. But then building your own C++ parser, that sounds like a pretty big project. So, has it been worth it? First of all, what have the challenges been?
Challenges in C++. Challenges start at grammar.
Right. Yep.
You know,
and often end there as well.
If I may propose a feature for some upcoming standards, can we please have a keyword for functions to define a function, declare?
You mean like FN or?
Yeah, something like that.
I have a proposal on the back burner for exactly that.
If you knew how easier it would make the job of a compiler to know that, because, well, we do recursive descent in the parser. So you take the grammar and you go left, right, from the top level grammatic rule and down to the bottom. You reach something like a literal there or an identifier or something, and you go up and you parse things. The problem is, by the way, recursive descent, because that's the only algorithm you can actually write, you can actually code, because others require some generated tables, state machines, and stuff like that. And recursive descent, it has some limitations it imposes on the grammar. For example, you can't have two rules in your grammar which start with the same thing.
Right.
That's why I want a keyword for function, because both function and variable, they start the same. You have type specifier, you have a declarator. And the difference is after the declarator, when you either have an initializer or parameters. And the other thing is left recursion. In your grammar, if you have left recursion, like a rule is defined using itself.
Right.
Usually it's for binary expressions, like, binary expression is binary expression, operator, and an expression with a higher priority. So the grammar of C++ is not well suited for recursive descent. Yeah. But everyone does recursive descent. Clank does recursive descent. GCC does recursive descent. We do recursive descent.
I think Microsoft does something else.
Maybe. I'm not sure about Microsoft.
So now they do a token stream-based approach, but I think that was in contrast to AST-based, which they now do more of as well. I forget whether they do it entirely now or whether they still do the thing where they backtrack when they... The original approach doesn't work anymore. They have to backtrack and then try an AST-based. But I'm not sure if that's the difference between recursive descent or not.
So I know a little bit about this. I have never written my own parser from scratch, but I have rewritten large parts of an existing parser when I was at JetBrains all the way back in 2018. I rewrote like large parts of their C++ parser at the time, which was written in Java. That was also fun. But that's a different story. But I remember that I like this kind of realization that I had, because when you, for example, want to parse a declaration or anything interesting, you have to there's all of these ambiguities where you have to try and parse it as a type, or try and parse it as a variable, or try and parse it as a function call or whatever. And then if it doesn't work, you kind of have to rewind and start again.
Yeah.
But a lot of the time, what you're actually parsing depends on whether some identifier X is itself a type or a variable, right? But in order to find that out, you might have to basically execute arbitrary const expr functions anywhere and instantiate arbitrary templates anywhere. And basically you have to interpret half your program sometimes in order to make sense. If there's a lot of const expr stuff going on, in order just to continue parsing. And yeah, I think that's the moment when I realized how messed up C++ actually is.
Yeah.
What's your take on this?
I agree that it's really messed up. From the, the worst part of C++ is C, really, because we have to carry that legacy. All those declaration syntaxes, which don't really make sense, they're inconvenient.
Oh, yeah. I did rewrite that specific part from scratch. I remember I found out just how many places you can surround something with parens and it still parses.
And wait until you get to function pointers, which get references to arrays and something like that, like a pointer to a function which take takes a pointer.
Yeah. You kind of have to parse it inside out, and it's kind of gets very weird. Yeah. I've been there and done that. I'm never going to do that again.
And you have to backtrack a lot, really.
Yes.
And another funny part is templates. But templates, like template declarations, they're easy because you have keywords, you have template, type name, stuff like that.
So yeah, that's actually context-free grammar, I believe, if you just stick to templates.
And when you get into instantiating them, it becomes real fun, especially if you have non-type parameters there.
Mm-hmm.
That's where you have to do a lot of those evaluations, which you probably want to avoid when you're parsing, because evaluating something during parsing, it's kind of out of place there. But you have to.
Because the whole meaning can change.
You have to calculate expressions and stuff like that. And you're lucky if you don't get some call to some const expr function which does recursion, God forbid. I'm not sure. By the way, I just thought about it. Can you do recursion in const expr context on
sure,
compile
why not?
time? You can, right? I was doubting for some reason.
Good idea to terminate it, though.
Yeah. By the way, about const expr, I always found it funny that the standard says UB is forbidden in compile time.
No, to a point.
And the same standard says that kind of UB, well, it doesn't say it explicitly, but it doesn't list every possible UB. So how can you as a compiler know that you have a UB?
There is some UB allowed at const expr now.
There's some UB allowed?
Yeah. I can't remember the details off the top of my head. I think there was a lightning talk at the CppCon that went into some of it, so I'll put a link in the show notes if that's available.
Well, I got something even more scary for you. Now that we get reflection on CppCast 26, we're going to have stateful compile time evaluation.
That's what I actually always wanted, but as a C++ user, not necessarily as a C++ parser writer. But I guess we'll deal with it as it goes.
Right.
But reflection will be interesting to deal with because you have to really generate code based on patterns, if I get it right.
Yeah, and like the thing about reflection, the way it's heading to CppCast 26 right now is that it's not really just reflection, because you can also splice back any of the entities that you're dealing with. So you can take a type, reflect on it, you get a meta type, you can add more members to it or whatever, and then you can splice it back and to an actual type, and then declare a variable of that type or whatever in your actual code, right?
I wonder how code completion tools will work with that. If I just take a class, add 5 methods, and then I declare a variable. Well, I guess they can get information from what you are writing in reflection for that.
You mean how code completion would work on a variable of this spliced back generated type? I guess the tool will have to actually execute the reflection code at compile time, just like it has to do today with like const expr stuff. Ultimately, it's another form of const expr evaluation, right? It's just like that. It also declares. It can now declare entities and do things like just normal const expr can't do.
I used to work with F# quite a lot, and one of the things that really impressed me in F# is type providers. And type providers are a way of generating code, not even that compile time, but that design time, you might say. You can actually have a type provider that will open a socket and load stuff over the internet and then generate code based on that. And you can do code completion on it. That just blew my mind. So hopefully we won't have that, but it does show what's possible. But I think we're going a little bit down a rabbit hole here. We should probably come back up to the surface. We started off talking about this in the context of static analysis. So in your deep dive into the murky world of C++ parsing, has any of that actually influenced what sort of things you actually might want the analyzer to look for? Examples of code that you think, we should never allow people to write that.
Well, not really, because parsing, static analysis deals with some specific cases, and parsing is for you want to do it in the most general case possible, if you can.
Oh, yeah.
But I certainly want to ban all intrinsics now of compilers, because I've seen a lot of things which don't even fit grammar.
Right.
Like in MSVC or Clank, I think it was Clank, it has in type traits, it has the isSame trait, which compares two types. And under the hood, it uses an intrinsic called isSame, and it looks like a function, but it accepts two type names as its arguments.
That's fun for a parser, isn't it?
Yeah, that was great.
Because that would look like a function type declaration to a parser or something like that, right?
Yeah, but we have a list of them. We just decided, okay, so they have names which start with two underscores. And since the standard says if you use such names, so expect anything. So we decided, okay, we just can't do it. We just write names of those intrinsics down and create custom rules for them.
Right.
So if we encounter the name, we will apply the rule which parses this intrinsic.
Mm-hmm.
So we are nearing our time limit for this episode. So I'd love to talk a lot more to you about static analysis and parsing and the deep depths of C++. But I think we have to slowly wrap up. Before we do that, do you want to quickly talk about the webinar that you're going to be doing next week?
Yeah, I'm going to be doing the one about parsing next week.
Mm-hmm.
I will be talking about all those problems with declarations, with backtracking, and how it leads to exponential algorithms, and you can get stuck. And I will touch on grammars a bit and how parsing works in general. Actually, we are planning to do a series of those webinars. So one is next week, one in November. It's going to be about semantics, I think. And one in December is going to be like kind of a continuation of semantics.
Right.
So yeah, I guess the link is in the notes, right?
We'll put that in the notes. Yeah, is only the first webinar available as a link so far?
Yes, because it's the only one scheduled, actually.
Yeah.
For others, we don't have a schedule yet, at least as set. But I know that the second one will be in November, somewhere first week probably of the month, and the third one, again, first week of December, something along those lines, at the beginning of the month.
Okay, so if you're listening to this in the future, then you'll just have to search for that one, but we'll put the link to the first one in the show notes.
I guess we'll have recording, so if someone doesn't catch it, you can always watch a recording later.
Great. Okay, well then we just have one final question for you, which is our usual wrap-up question, which is what else in the world of C++ do you find interesting or exciting, or in the case of static analysis, maybe dangerous or challenging?
You know, the more I write in C++, the more I understand why functional languages exist. Which is
very
funny.
Interesting take.
Yeah. So, I don't know. I guess C++ likes to borrow good ideas from those languages, like the ranges library. I guess I would want to see more stuff like that.
Right.
And maybe help other finishes his CPP2 and we will be using a different syntax at some point.
Maybe.
Oh, yes, and please ban C arrays and C casts. They are evil.
Right. Yeah, if only we had tools that could analyze your code statically and spot these things. That would be good.
If only.
Well, thank you, Yuri, for coming on this episode, being our guest, talking about static analysis and parsing C++, and all of the depths of the rabbit hole that can take you down. So, thank you for your time, and we look forward to your webinar. Anything else you want to let people know, like where people can find you or follow you?
Well, not really. The thing about me, I'm not really a social guy.
Right.
So I guess maybe I'll visit some conferences at some time.
Okay. Then all the more reason for people to catch you while they can in your webinar. So, yeah, thank you.
Right. Thanks very much, Yuri.
And thank you for letting me in. It's been a pleasure. Really.
Thanks so much for listening in as we chat about C++. We'd love to hear what you think of the podcast. Please let us know if we're discussing the stuff you're interested in. Or if you have a suggestion for a guest or topic, we'd love to hear about that too. You can email all your thoughts to feedback@cppcast.com. We'd also appreciate it if you can follow CppCast on Twitter or Mastodon. You can also follow me and Phil individually on Twitter or Mastodon. All those links, as well as the show notes, can be found on the podcast website at cppcast.com. The theme music for this episode was provided by podcastthemes.com.